Greetings and welcome to my new calculus channel. My name is John Gabriel, and today I'm going to be continuing with propositions 17 through to 20 of book 7 of Euclid's Elements. So let's begin. Now, proposition 17 says that if D is equal to AB, then and E is equal to AC, then D over E, not D in ratio to E, is equal to B over C. So Heath actually got this wrong, okay? So it's evident that Heath did not understand what Euclid was writing down or even attempting to elucidate in the elements, because Heath mixes proportions of numbers like these, okay, with ratios, and confuses the measure of ratios with their proportionality. So whilst D is equal to AB and E is equal to AC are equalities, whence we get equations, D to E in proportion to B to C are proportional ratios, where D to E is not necessarily equal to B to C. And why is that so? We'll see in a moment. It's not as if we haven't seen this proportion or a form of it in book 5, but the emphasis here is to prove that it works for numbers as well. That's why there is a book 7, because it's a transition from magnitude to number. That is the measure of ratios, and more importantly, to establish the operations in algebra. So correctly written, it would be stated like that, okay? No ratios there whatsoever. So from ratios to measure of ratios to number to algebraic operations, we see this method continue in the remaining propositions of book 7. And the correct statement should be the one that you see here. If D is equal to AB and E is equal to AC, then D over E is equal to B over C. And all the symbols denote numbers. Now, propositions 18 and 19 elaborate further on these algebraic operations. Let's just compare all of them. So 17, we have this statement, and 18 this statement, and in 19 this statement, okay? And I'm going to put this in the detail section, so don't worry too much about it right now. But evidently, this proportionality does not imply that AD is equal to BC and vice versa, okay? Moreover, the symbols decidedly do not all denote numbers, okay? So here we're not talking about numbers, because if we're talking about numbers, we can't write it like that. We have to use a vinculum, okay? Because a number is the measure of a ratio. So for example, if we've got this proportionality here, this ratio in proportion to this one, that does not imply that 1 times 4 is equal to 2 times 2, because this antecedent is not equal to this antecedent. However, the measure of this ratio and the measure of this ratio implies that 1 times 4 is equal to 2 times 2, okay? So this is a very subtle detail which Heath completely missed, given that he did not understand, and also all the morons of the last 2,000 years also did not understand the motives behind Euclid's approach. Mainstream mathematics academia is incorrigibly stupid, arrogant, and vile. So they cannot be corrected. Now, if Heath had instead written A over B is equal to C over D, then AD equals to BC, then it would have been correct, okay? But the ratio of 1 to 2 meant, if indeed the ratio of 1 to 2 meant the same thing as 1 over 2, then it would make no sense to have included once again most of the propositions in book 7, since they are covered in book 5, right? Makes no sense. So let's just look at a summary of this. In geometry, this proportionality states that this ratio here, is in proportion to this ratio. They are decidedly not equal, okay? Under no circumstances. However, in algebra, where the size of the abstract unit doesn't matter any longer, the measure of this ratio, which is a number, is equal to the measure of this ratio, which is a number, and that number happens to be a half, okay? And we'll see how this is elucidated further in proposition 20, where we begin to talk about equivalence of fractions and irreducibility. So a number is a name given to a measure that describes a magnitude or size. This was the first time number was well defined, by myself, of course. It takes an absolute genius to understand the elements of Euclid, and I am that genius. Now, Proposition 20 says the least numbers, here it is, the least numbers of those having the same ratio, measure those having the same ratio as them an equal number of times. What this is telling you is this. It's telling you in simple words that we have a concept which is the irreducible fraction. Okay, so if we start, for example, with 70 over 112, and we divide both, we simplify it by dividing both the numerator and denominator by 2, we have 35 over 56. And finally, we have 5 over 8, which is irreducible, okay? And that's all that Proposition 20 is saying. So I think I'm going to stop here because I'm a little out of breath, but I'll continue with the propositions sometime in the near future. If you're not already a subscriber, please become one. And also click like and share this information with your friends. I am being targeted even by the vile administrator morons at Google, because I've noticed that every time I get new subscribers, they constantly reduce the number of subscribers. So it seems to me that they are messing around with my numbers, but I don't really care because all these videos are being backed up to Odyssey, and YouTube can go to hell for all I'm concerned, for all I'm concerned, for all I care. Now, this information is not printed or published anywhere. I'm telling you this for the first time, okay? And so I'm going to put these things in the details section and you can study them. So without further ado, I'm going to say goodbye and I'll chat to you soon in the very near future.